Yeah. Perfect. Thank you.
Okay, good.
Okay. So, do you have any questions, first of all?
Uh, I
Something to
think
work on the.
no question, but just in the past 2 weeks, I did some like DFS questions and dynamic programming questions. Not too much, but still learning like BFS. I'm not very understand it. Just still in the process of learning it.
DFS, but you're good with DFS.
Yeah, I think I can do DFS.
Okay.
Mm.
Do you have a problem that you want to solve together on DFS?
Uh, I don't think I have any problem actually.
I can give you a problem.
Yeah, please.
Okay. There's a famous application that uses. Well, okay, I'm not gonna use you. I'm gonna tell you. Not gonna tell you what it uses, but um, in a grid, the shortest path in a grid. Do you know the problem?
Uh, Show me. And I'm not sure if I know this question.
Do you have the Leetcode Premium?
Sorry?
Do you have Leetcode Premium?
No, I don't have.
Okay.
Mm. What's the difference? The premium account and the normal account?
Uh, with Premium, you can access to some solutions because some
Okay.
solutions are only for Premium, and
Oh, yeah.
some problems are also only Premium. You can
Okay.
access to the lists of problems per company. That's
Mm.
also per Premium. I asked a couple of friends, and they recommended it, to be honest. I know a friend who works for Microsoft, who got an offer. He works there now. He's the one who suggested that I get um, Leetcode Premium, especially if you're targeting a company, because
Uh,
you can work on many problems that are very close to the type of problems that the company offers.
I see. I don't know if they have like a student account. If they have student account, I can just open a premium. Probably they would have a discount for student.
Yeah,
And
that's probably.
I usually use a China's lead code account, so I can see some solutions or some unlimited problem solutions in a
Mm,
Chinese.
I see. Well, I don't find the problem, but I can describe it or write it down. It's very simple. So,
Okay.
what you have, um, okay, can you share your screen and open a playground? We will work on Leetcode playground. I will write you the problem there.
You mean a lead code page?
Yeah, you know
Is that
Leetcode. Share your screen. I'll tell you what to do.
lead code?
I didn't share documents with you on problems that I share with my other students, right?
You shared with me one document. I think there's some problems. Let's see.
We can work on some problems from there, if you don't mind.
Yeah. Yeah.
Are you able to share your screen? Hello?
Yeah. Let's try. Yeah, I can sharing. Let's see. Try. Second. See. Okay. So.
Okay. Go to playground. That's right there. Next to premium, right from premium. Yeah,
This
right.
one?
Yeah, this one. That one. Yeah, new playground.
Okay.
What?
Wonderful. What happened?
New?
Okay.
Well, okay. Just I'll try to write the problem. Okay, so what you have is a grid like this. Uh, this is you have the source and destination. So find the shortest path from S to D given a grid. Okay, so you use Swift, right? Yeah, I'll just write this, and then you make it shortest. Vector.
Yes.
So for the input in C++, it's a vector of vector string grid. Okay.
Okay.
Or actually, it's just a vector string because the string is already.
What? Let's see. Green.
This is string 1, string 2, string 3. Yeah.
So do you think the vector is the same thing with array?
Vector is dynamic array.
Okay.
Okay. Is the problem clear?
Okay, let me think about. One, two, five.
And you have to look for S and D. You have only one S and one D. You only have one source labeled as S, one destination labeled as D. You have to look for them first. And return the answer.
Okay, so what about other items? Is like a character or a number?
They will contain dots like this. I'm gonna add obstacles. I'm gonna add obstacles like this. So this is an obstacle.
Okay,
You can go here, 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 here. Yeah, but you can. This is like a wall. See?
Oh, I see. It's like a special character, right? Just the dots. A short is past.
Here, answer is 1, 2, 3, 4, 5, 6, 6. Output 2.
Okay.
Is it clear?
Give me 1 minute. Think about.
Yeah, sure, sure. You can.
Do you think any canvas in this page I can use to like draw some draft or
Sorry?
I mean any canvas in this page I can draw something.
I don't think you can draw over here.
Okay.
Do you want to draw?
Yeah, I just
Yeah, you
see
can.
that.
You can open an app and draw.
Let's see if I can try this. Can I ask you this part? What was the difference of this character and the dot? I mean, can I just pass by this one?
No, you cannot. You have to go over
It's like
there.
a block.
Yeah, it's like a wall.
Okay.
Can you tell me what are you thinking about?
I'm thinking about I probably can use DFS to solve this problem.
Yes, you can.
Like, yeah, like if I start from the left top corner, actually I can only go right or go down. It's just two ways. So
Yeah, you can try. You can start with DFS. It's not a bad
DFS.
start. Yeah, DFS.
Sorry, say against DFS or BFS?
Did you say DFS or BFS at the start?
A DFS.
Yes, I said. I confirm. Yeah,
Okay.
DFS. You can start with DFS.
Okay.
Apart from DFS, do you have any other idea?
From S. So I had to start from S, right?
Yes.
And what is the output? Is like integer numbers. You can shortest the path. What is shortest path?
I'm sorry. What was your question?
Oh, yeah. I'm seeing. It's output. Okay. I see. It's output.
Yeah. So the shortest path is the number of steps to reach destination from source.
Okay.
Jing, I need you to say what you're thinking about. I cannot just wait, you know.
You know what? I still trying to figure out the solutions.
Yeah, just tell me what you're thinking. Yeah,
Okay.
anything in your head. Just
Okay, so I think the first thing I had to find out the start point, like I had to find a position of S. And this grid is like two-dimensional array.
yeah.
And so I guess I probably just iterate this two-dimensional array.
Yeah.
Like I can only go right or I can go down.
Uh, you can also go up and left.
Oh yeah. Oh, go left. Okay.
Okay, maybe I wasn't very clear. Okay. So the grid contains S. So this is S for source. D dot for empty block, and for the wall. You can go up, down, left, and right.
Okay, I see.
Okay, just let me stop a bit. So SI, SJ, DI, DJ. So you have the source and destination. Okay, so we don't have to waste our time to look for them, okay? So you can start, so you can go up, down, left, and right. You have these, and you just have to find the path from that point to D.
Okay, I see. Can I ask you what was the meaning of this SGDI? What's that?
Okay, just I'm sorry about this, but this is the last time I'm modifying the problem. I'm just trying to make it simple because I just want you to do some graph application. You know, I don't want the rest to be confusing. So
Okay.
I'll just create S. The source is the top left cell, and destination is the right bottom cell. Now let me modify.
Okay, I see.
Okay. Return -1 if there is no path from S to D.
Okay. It seems like an easy version than last one.
Yeah, I'm just trying to make it simple so that you just focus on the graphing. Okay? Okay, so here, 1, 2, 3. 3.
Okay, so if I just go from left to the bottom right item, I think I don't have to go up, right? I only just go down and go right. I think I don't need to go up and left. Oh no,
Hold on. Let me
there's some
explain.
block.
So look at this grid, for example. The shortest path, you have to go here, like this, and that's here's, and all the way, like this. See how long it is? So 1 step, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay.
So your source is at 0, 0, and destination is at the very bottom right corner.
Really hard.
Okay, I can help you. So you said DFS, right?
Yeah.
Okay, I'm at I. I will write UI, UJ. So this is point U, and j. Okay, it's like x and y, or row and column. Okay, what I will do is I'll create for up and down d. It goes like this. One, 0. Do you know dx and dy? You know these arrays for grid pathing.
dx, dy. You mean two individual array or two-dimensional array?
Okay, so this is respectively. So here, what we will do is we will do vi, which is ui plus dx of I. Then vj equal vi plus dy of I. I know it might sound look. So this is where we are at. This is like the point or vector.
Okay, you mean the start point of the vector?
Yeah, this is the start point. So
okay.
1 here, we add 1 to the x and 0 to the y, which make us go bottom, respectively. Bottom, then minus 1 to the row, up. Here, 1 to the y, that's right, and left. Because here, look, you start from 0, 0. You start from 0, 0. Going right is 0, 1. Is adding vector 0, 1. So this plus this equal the new point, this one.
Okay.
Is it clear? Yeah. So that's what these vectors are. This is bottom, up, right, left. We tried the 4 directions. We go to 4 directions. Iterate over all possible 4 directions. Here, you have to check if it's valid or not, that it's not out of the grid. Check that cell is not out of the grid. And also check that cell is not a wall. If this is done, then what you do, DFS, the new point, VI, VJ, of course, visited. If not visited, VI, VJ. And as soon as we visit, we mark as visited. Go through. This is the BFS. DFS, sorry.
Oh, I see.
Is it clear?
Yeah, it's clear.
Can you make it BFS? Because
no,
this
you know what? I still cannot write the BFS. I just start learning the BFS. You mean BFS, right?
Yeah, BFS, breadth first search. Yeah.
I'm not good at BFS, so I can't write the code.
Okay. Do you want me to write it for you and you modify it? I'm not gonna make it complete.
Okay. Uh,
I feel that this problem is not the best for you because you told me that this is the simplest application using BFS. It's really the simplest.
you know what? I think we can talk about BFS next time.
Okay,
Mm.
no problem. I'm really sorry, but when you first mentioned that you want to do something about BFS, then I said that, okay, let's do something simple with BFS.
No problem. I said DFS. Probably just we understood.
You want to do DFS?
Yeah.
Okay, you know
You
what?
know,
I'm going to give you a problem that you can do with both BFS and DFS.
Okay, good.
Do you know connected components?
No, I think.
Okay, let me show you that.
Okay.
Yeah. Mm. You know what a connected tree means?
Which one? Sorry, can you say again? I didn't catch your last sentence.
Yeah, hold on. Do you know what a forest means?
No, I think.
Can you type
Um,
forest versus forest tree graph? Or can you please fix the keyboard because I cannot type.
yeah, I fix it. Try.
Okay.
Forest and tree
Yeah.
graph.
Yes. So, okay, first let's start with a tree. Do you know what a tree means? Definition of a tree.
Yeah. Uh, like tree has a road and like left, right, nodes. But that is binary, right? Um,
Yeah, a binary tree has two children per node.
yeah. So I
That's
guess the tree is just like also has a road and has like several nodes, like several children's come from the parent. Yeah. Let's see, a tree is connected.
yeah, this is the definition of a tree. Connected, acyclic means that there is no cycle.
Okay.
Undirected means that you can go both ways. And connected means that all the nodes lead to each other. Each node can go to the other node. There's a path between any couple of nodes. This one, pick any node, this one and this one. There's a path between these. You can go like this. Pick another couple, this and this. There's a path here and here. Pick another couple, this and this. There's a road, this one. Hello?
Hello. Okay.
I'm sorry, I don't know what happened. Super
That's
sorry.
fine.
Okay. Allow me to take control again. Okay, so this is, I was saying connected means that there's a path between each pair of nodes. So in this tree, for example, pick any pair of nodes. This node and this node. There's a path, which is this one. Pick another pair of nodes. This one and this one. There's a path. Here is the path. That's what a connected means. For example, this here, this is not connected because this node and this node, they don't have a path between them. So that is not connected here. The graph is not connected. But this one is a bunch of trees together. So tree plus tree plus tree, we call it a forest. Many trees, okay? So I want you to write a program that that tells if you have a tree or not.
Have a tree or not?
Yeah, is it a tree or not? So for example, this graph, this cycle, there's there's this cycle, and it is not a tree.
Okay.
Here,
so the second one is also not a tree, right? But it has trees. Or did you mean at least one tree is okay?
yeah, this one it's a tree, so you're good. But
Okay.
what we do not want is have many trees like here, or a cycle. We don't want to have a cycle.
Yeah.
Okay. So what I'll give you is sorry. So your function signature goes like this. Bool is tree. Vector of int vector g. So this is the graph. This is the adjacency list. Okay.
Okay.
Return true if this graph is a tree. Otherwise, return false. If there is a cycle or not connected. Not connected. Yeah, and you are given an indirected graph. So it means that this condition is already there. You just have to check that it doesn't have any cycle and it's connected, okay? We can start with the first one. If you want, we can first check if it does have a cycle or not. Let's go here and answer the same problem. So has cycle. All right. Cycle. Return true if this graph has a cycle. Okay, let's start with this one.
Okay, let's see.
Let's look at some graph.
I'm a little confused about the vector, the G. I mean, what it looks like inside is every element, what element like a number or or a character. How could I iterate this?
Yeah, hold on. It's in the adjacency list. Graph editor CS Academy. Okay. So adjacency list means that one will have 4 and 5. This is the adjacency list. Here, adjacency list. Let's create a simple tree.
Okay, just like the matrix, right? The left
Yeah.
matrix.
The matrix will tell you if 0 and 1 are connected. If they're connected, there's 1. But with adjacency matrix, a list, sorry, at 0, you will have 1. 1, why? Because 0 has 2 neighbors, has 1 and 7. So these neighbors, you will have them in the list.
I see.
7 has 2 neighbors, 8, 9, and 0. So at 7, you have 0, 8, 9.
I see, I see. You know what, when I solve the problem of tree, they usually give me like a tree node, so I can just go left and go right.
That's
So,
a binary search tree, but sometimes you're given a graph.
okay.
And and my question is that graph a tree? And a BST is a binary search tree. So is a tree. You know, we cannot check if it's a tree or not because it is a tree.
Yeah, yeah, yeah. Let's see. Can I ask you a question? How did you usually just iterate this matrix? Like you just start from the row and to see which element is equal to 1. If it's equal to 1, it's like a node. And you just iterate out every element to see. I don't know. I never did this kind of matrix, but
How did you do how did you do BFS? You said that
you know, the thing I know BFS is I only know it's a queue. And every time I just like I iterate every layer of the matrix and put one layer's element into a queue. And
G, let's say
you know what? It's,
yeah.
I feel I did a lot of not a lot, some questions of like a binary tree and the DFS, but when you give me a new question, I still have no any idea how to solve the new questions.
I see.
Mm.
But tell me, did you use adjacency list before?
Sorry, say again.
This is adjacency list. Did you use it before?
No, I think no.
Yeah, so it's normal. It's not a big deal because what you have done in the past is dealing with binary search trees, and you didn't go deep in problem, in what is a tree, what is a forest, the definition of a tree is a cyclic, da 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 da. And my job here is to give you to push you to the limits and to give you problems that you cannot solve. And we have to solve them together. And I need to see you how you solve them.
Yeah, sure.
See?
Mm.
I cannot give you problems that you already know how to solve. And that's why I asked, do you have any question at the start? Do you want to do something together? So that's, I mean, since you said that you're new to BFS, it's a bit confusing. So I'm trying to, make you practice some application on BFS. That's what I'm doing here. So
Okay.
it's normal. The fact that you're struggling, it's normal. And that's why I'm helping you. You see, I have I have made the problem simpler so that you understand more. And this problem, we will come back to it sometime. And I changed the problem to make you work on a simpler problem so that you understand the bigger problem later. Okay. Um, okay. So for adjacency lists, let me show you how we do like normal DFS in um, an adjacency list. So we mark as visited, then you iterate over V in graph of U. So this is iterate over children of graph of U, or over neighbors of U, we'll say. V. If not visited, V is not visited, then visit V. Not visit, sorry, DFS. This is DFS. This is it. That's it. DFS on a JCC list. And we can run it. Okay. So G of 0 equal to 1, and J of 1, 0, let's do visited. I'm sorry to write C++ because I want to do something fast to show you. Visited in size, size. Here I'm initialize this array to false, and I have to make this
Why you set this 0 and 1? Just 0 and 1.
Yeah, I'm just creating a graph.
Okay.
I'll do 3, 0 goes to 1 and 2. So this graph is like this. It's 0, 1, 0, 2. This is my graph, okay? So 0 has two neighbors, 1 and 2. 2 has only 0, 1 has only 0. And that's what I did. 0 has neighbors 1 and 2. Is this clear?
Yeah.
It will be clear. Just hold on. DFS 0. Okay, finished with, I didn't print anything, so I want to print.
Do you think it's different when we like initialize a graphic in using C++ and other programming language?
What is different?
Like when you initialize a graphic.
Oh, I don't use Swift a lot, to be honest, but I don't think it's very different. So I'm just initializing an array here. That's it.
I see.
Okay, do you see? 0, 1, 2. So I explored, I did DFS. DFS from 0. I started exploring from 0. And this is the graph that I explored. So 0, I went then to 1 and the 2. So let's add another node, 3, that's linked to 1. I will add this edge, 1 to 3. Okay, so it will become like this. 0, 1, 3. Let me add it. So the size is going to be increasing. 1 to 0 and 3. And g of 3 equal to 1. So 0, 1, 3, 2. Look, 0, because we do depth first. 1, 3. Then 2. Let me show you. Look, I'm going to do some other print lines. We are at U. Okay, now let's print the edges. Going from U to V. Okay, we are at 0. Then I can use maybe not open. Fine. Let me split this way. So we start at 0. Then from 0 we go to 1. You see, from 0 to 1. Now we are at 1. From 1 we go to 3. From 1 we go to 3. And at 3 we are at 3. Then going from 0 to 2. From 0 to 2.
I see.
Clear?
Yeah, I think so.
So this is DFS, depth first search, on adjacency list. Now, do you know how the adjacency list works?
How what works? Say again.
The adjacency list.
No, adjacent list.
Yeah, this is the adjacency list, this one. Okay, can you tell me what this means in the adjacency list? Why 0, 1, 2? Can you explain this?
I think it's like in a two-dimensional array, the first inside the first element, there are two elements, which is 1 and 2.
I wrote it down here. Is it clear that 0 has neighbors 1 and 2? Look, 0 has neighbors 1 and 2.
Yeah.
Okay. And this, what does it mean?
This means 1 have 2 neighbors, 0 and 3.
Can you verify that in the graph? Can you show me in the graph?
See, 1. So that means the 1 has a neighbor 0 and 3 in this graph.
Yeah. Is it clear?
Yeah, it's clear. Let me see 2. Let's see 2, 0, and 3, 3, 3, 1. Okay. But for example, if I add a new element like G C 10 equal to 1. Let's see if we add a new element like 10 equal to 1. Do you think it's add a neighbor of 1? Like I just add a new neighbor in here.
Yeah, you can. You can.
Okay.
Can you add it? Can you do it?
I can add it here. Okay.
You linked it with 2. Did you want to link it with 1 or 2?
Sorry. You know what? I sometimes I can hear you very clearly.
Oh, I'm sorry. Is it better now?
Yeah, I think I understand a little bit.
Okay. Sorry.
You
I
know
was
what?
saying.
I think you probably can just leave me several problems, like some problems on the Leetcode and related to the graphic. So I can spend some time to solve those questions to understand how to solve the problem of graphic.
But before that, we need to get. We need to do more recursive and DP. That's what I think. If you insist, if you want to go do graphs, then okay, I'll give you some graph problems. I suggest at least we do some more recursive problems.
Okay, we can go ahead.
But I will give you like 2 or 3 problems, and you can solve them whenever you want. If you have a question, let me know.
Okay, good.
Okay? But there's, so here you link 10 with 1. But here you link 10 with 2.
Oh yeah, I can link with 1. Change this part.
Yes. Okay. Now let's try to run. Can you try to run the code and see what happens?
Which one? You see here?
Yeah. Can you run the code?
Oh yeah.
Oh, yeah. Sorry. You have to increase the size. Where's 10?
The size means the range of the array, right? The boundary of the array.
Wow, this is not.
You know what? Because I'm not very familiar in the C++, and I just guess resize means set bound arrange or how much elements of the array. Mm.
Oh, yes, but you have to do it both ways. You have to add here 10. That's why. It's not printing it, but now it will print it. Look. See?
Uh, oh yeah.
Because we have undirected graph.
Mm.
And in undirected graph, you add 2 edges. This is an edge. Look. Here, 10 to 1. When you do 10 to 1, this is an edge. This.
Yeah,
In adjacency list, you need to add 2 edges. 10 to 1 and 1 to 10.
I see.
When you have an adjacency matrix, what you do is you add 1 in both here. 0 to 1, 1 to 0, you see?
Yeah.
And adjacency list, 0 to 1, 1 to 0. We can do tree, binary tree, disjoint. Anyway, so I will give you some graph problems. I have already some basic problems that I have wrote in the document. Do you want me to create and share a document with you so that you
Mm,
solve?
sure.
Okay. Okay, I'll do that. So the problems that I wrote there, they're like the base of graph problems, and when you do them, when you're good at them, uh, you are going to be able to understand other graph problems. If you're not good with the basic problem that I gave you, then you're going to struggle. You see? So they englobe the basic tricks in graph problems.
I see.
Uh, okay. Do you want to do something together now, or what do you want to do?
I we can do, but I'm not sure if I can solve the problem. How about we can try to like do some pretty simple like uh, DFS problem or dynamic programming problem.
Dynamic programming. Okay, show me the
Mm.
problems that you have solved. Let me see it. So I need to
Okay,
see.
yeah, I think I should show you. I show
Okay,
you
show you.
what problem I solved. Okay, stop first. Okay, so that's my document. I just copy the problem I solved on this document, like the integer break. I found some image online actually. And unique path.
Oh, you solved unique paths
Yeah.
on Leetcode, right?
Sorry.
There's a unique paths problem on Leetcode. Did you solve it?
Yeah, the same one. You say is the 62
Okay.
problem. Yeah, and yeah, actually, I think this one is pretty like the problem you give me. Is sometimes like there's a wall you cannot pass by, you cannot go right or go down, this kind of thing.
You want to do it?
I can do it, but I'm not sure if I can. I can write the code. I, you mean this one?
Yeah.
Yeah, let's see what needs the solution. See the 62. It's a DFS solution, but this solution seems that cannot pass because it's has time limited question.
You want to solve it together?
Yeah, I think we can solve together. This one.
Okay. Can you show me the problem so that I read it?
Mm.
Oh, unique paths. Okay.
Yeah, do you mean unique paths?
Okay. Whatever you want. Whatever. You can do unique paths.
They changed the UI of the Leetcode page.
Yeah, I didn't pay attention, but I saw that on your machine.
Mm. This one, let me see. Yeah. Okay. Let me see one more time. I see the DFS and yeah, they also had a solution of dynamic programming. Looks like okay, good.
Okay. So tell me which one you want to work on, or if it's because you seem to have accepted solutions.
Mm, I did like both way of DFS solution and dynamic programming solutions in here. So
Okay.
I
Can
don't
you
know. Do you have
okay? Can you delete the code and start again?
oh here? Okay, good.
Okay. Which one you want to start with? The person?
We can try like use DFS first.
Okay.
Hopefully I still remember the solution. Okay.
Okay.
See, okay, so the input, like, let me read the question first. I will miss. Okay, top corner. That's great. So the input M and N means the width and height of this grade. And right now I had to start from the left top corner to the right bottom corner. So how many possible unique paths are there? So that's mean I can there are a lot of ways I can go the right bottom corner. So I just try each kind of ways, and finally I had to accumulate um, how how many ways I can walk to there. So if I use DFS, I actually in each case like I iterate the right direction and down direction. Let's see, and like I had to find a base case. That means I already arrived at the destination. And the whole process like a bottom up, and I just iterate to the last point. And I think once I arrive to the destination, I just add this path to like my results. Like if I initialize a rate for the results, but it just should be just a number. It's just a +1. That means I found a path.
Yes. Yeah.
Okay. Let's. Do you think I just write the code? Try to write the code.
You can write the code.
Hopefully I can. So first of all, let's see the constraints.
Jing, can you start a timer?
Start what?
A timer.
Oh, timer. Okay.
Do stopwatch. Stopwatch. Hold on. No, stopwatch. Yeah. Okay. You have 10 minutes.
2 minutes.
10.
Okay. Good. Okay. I initialize the result to the row. The functions code. Okay, so I need the parameter. Let's call I think it's If x let's see. Oh, so
Okay. So yeah, the approach is correct. After you finish this, can you remove result and make the function return the result?
remove it, say again.
Remove result as a variable and make the result in the function itself, DFS.
You mean return result in this function?
Yeah,
In the
and remove result as a variable.
okay, let's try.
Uh, just hold on. Let me show you quickly. I'm gonna go for some 10 minutes, and I want to close the session. Let's put it back when I come back. Okay. So the result, I want the result to be here.
Mm,
like this. So this has to be removed,
okay.
and you have to return an integer. I don't think you should here. You do int, right? Like this.
Mm. Correct.
Is it clear?
Yeah.
Okay. Be right back. Should be less than 10 minutes. Okay.
Okay. Mm.
Hey Jing.
Hi, you back?
Yes. Okay.
Oh, Saturday 20.
When did you finish it? Like this?
Yeah,
Is
finished.
is it correct? Oh, cool. Okay,
Describe.
so this is DFS. Do you see any problem with this solution?
You know, I just suddenly very confused. I don't. I know in this way I can get the right result, but just for the return is actually a little confused. I don't know how to analyze the whole process, like how to
Uh, can
count the
you?
result.
Okay, I can tell you what to do. So can you return the resume the session counter on Code Mentor?
What?
On Code Mentor, can you resume the session because we paused the session?
Oh, yeah, this one you mean. Okay, okay.
Yeah. Okay. So what is the complexity, the time complexity of this solution?
Time complexity.
Yeah.
Um, I think is 2 to the n is, yeah, 2.
What makes you think it's 2 to the n?
Because it's just like a binary tree. I feel like every time I either go right or go down, and it's
Mhm.
like every layers it's like 2 to the uh, how to say it's 2 to the layer, the current layer, and the bottom layer is like how let's
Mm,
mm, mm, I
Okay,
don't.
so the answer is actually correct. It's 2 to the n.
Oh, okay.
But I want you to understand why is it 2 to the n.
Mm,
So it's when you compare it like a tree, that's right. So remember when we talked about the branching factor and the depth of the tree?
mm.
Yes. So what do we have here? What is the branching factor and what is the depth of the tree?
The depth of tree, it should be m or n. It's depend on which number is bigger, or let me think about.
Okay, let's think of, okay, first, what is the branching factor? Since it's easier, what is the branching factor here?
Ration factor.
Yeah.
Uh, ration factor. But sorry, I don't know what is ration factor.
In the tree, like how many branches each function opens? 2, 3, 4, 5. In binary search tree,
It's
the
2.
it's 2, yeah, because each
Mm,
function calls 2 other functions.
yeah.
Yeah, and here.
Here is 2.
Why is it 2?
Because it only like it's x plus 1 or y plus 1 in the code. Like I can only go right or go down. So
Exactly.
every time.
Yes. So you have 2 choices every time. You have only 2 choices, and that's your branching factor.
Yeah.
Now let's go to the depth. So allow me to have control.
Okay.
So when you are here, I'm gonna. So dfs of 0, 0. Here is gonna call dfs. Is gonna go down. So 1, 0, and this one calls dfs of 0, 1. Okay, this one goes to the bottom, this one goes to the right. And then this one can go right, and this one can go left. And when that happens, they go both to 1, 1. But I will come back to this. So step 1, 2, 3, 4, 5, 6, no, until the finish. So we will be opening 2 branches at each step. So the branching factor is 2. And the depth of the tree is the number of steps from start to finish. Is that clear?
Number of can you explain one more time how to account the depth?
So here you have 2 options, go right or left. For many times, for many steps, here, 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 here you have 1 option, here you have 0 options. But you will pretty much have 2 options until you go all the way from start to finish, which is the number of steps from start to finish.
Okay, yeah. So it's like m plus n.
Exactly. This is what I was trying to show. So you got it correctly, pretty fast. Good job. Okay. So that's the complexity. Time complexity, it's O of 2 because we have 2 options, go right or down, to the m plus n because we have to go all, I mean, the 2 options is repeated all the time, all the way from the start to the finish. That's how it goes. Okay. Now let's look at m plus n. M plus n is around 200. And do you think is that slow or is it fast? What do you think?
200. It's probably very slow.
Hold on. Oh, I opened. Okay, so hold on. Look at 2 to the 100.
Wow.
E60. Look at 2 to the 100, e to the 30. Look at e to the 50. What? Oh, not 500. E15. When we have an exponential function, we can go up to 17. 17 is doable because it's around 10 to the 6, no, to the 5. So this is approximately 10 to the power of 5, and it's doable. But more than that, you cannot do. So this is too much for exponential functions like 2 to the n. You can go up to 17, where 2 to this 2 to the 17 is approximately equal to 10 to the power of 5. So this cannot pass. You need to think differently. Or there's might be an optimization. Do you think there's an optimization, first of all? And you can hit submit and you will see
I
that.
remember, yeah, I remember they can save like some middle nodes in the process, and if they account this nodes before, they can just return this nodes from like for example, if from an array, because you storage all of the process in the array, so you don't have to account duplicated for the same node.
Yes, like this one.
Yeah, like this one, DFS 1 and 1.
Yeah, okay. What can you do?
I think I can initialize array to initialize. Yeah. Let me see where I should initialize. I'm thinking about initialize inside or outside.
Oh, I'm sorry. It looks like I have some connection problems that I need to fix. Are you there, Jing? Jing, do you hear me?